Hey, what's up everybody? This is Mr. Decker. This is going to be lesson 3 in Unit 2. Unit 2, we're focusing on the foundations of geometry. This lesson about conditional statements is important because a lot of the theorems that we work with are in fact conditional statements. Conditional statements are really just if-then statements. This is just like really like a summary of everything that we're going to talk about today. So a conditional statement is like if something happens, then this is the result, or if the hypothesis, then the conclusion. What we're going to do is practice writing conditional statements given a hypothesis and conclusion, and then we're going to understand and interpret the converse, the inverse, contrapositive, and biconditional of a conditional statement. This actually might be a good lesson just to flip through the PowerPoint versus watching the video, but I will try to be concise and quick through this video here. So first off, what is a conditional statement? A conditional statement is if-then. So those are the two key components. It has to be an if-then statement. That's what makes it conditional. So if the hypothesis happens, or if the hypothesis is true, then the conclusion must follow. So an example of a conditional statement would be, if you are at least 18 years old, then you can vote. So that's an example of an if-then statement. Now, Jeff Foxworthy is actually the king of conditional statements. You might know him as the host of Smarter Than a Fifth Grader. But before that, as a comedian, he always had these jokes that if you mow your lawn and find a car, then you might be a redneck. This is an example of a conditional statement. I know that was cheesy, but whatever. So identifying hypothesis and conclusions is part of this lesson. So in these if-then statements, if you mow your lawn and find a car, the very first part after if, this is always the hypothesis. Everything that comes after the word if and before then is your hypothesis, and then everything after the word then is your conclusion. So again, if this in this conditional statement, the hypothesis or the statement is if you mow your lawn and find a car, that's the hypothesis. Then conclusion, you might be a redneck. If you want to just try to play along real quick and try to figure out what these other ones are, I believe this part's pretty straightforward, so we'll kind of click through it here fast. So again, the second one says, if you don't clean your room, so you don't clean your room, that's our hypothesis, then you're not going out with your friends tonight. That's the conclusion. So again, these are conditional statements, conditions that need to be met. You can think of it that way. If then is always how we read them. So if two sides of a triangle are congruent, then it's an isosceles triangle. This is actually an example of like a theorem that we're going to look at in class. So I included that here so you can see where it's going to come up in geometry. Now, writing a conditional statement. The way that we write a conditional statement is basically take the hypothesis and conclusion that they give us and write it as an if-then statement. So on this slide, it says, write the following statements as a conditional statement, then determine the conditional statement's truth value. Whenever they're talking about truth value, they just mean if it's true or false after you write it. So first off, an obtuse angle has a measure greater than 90 degrees. So we could say that if an angle is obtuse, then it has a measure greater than 90 degrees. That would be a conditional statement. And that is the definition of what obtuse is, so that's a true statement. Next up, we have states on the East Coast border the Atlantic Ocean. So if we wanted to write this as a conditional statement, we would say if a state is on the East Coast, then it borders the Atlantic Ocean. So hopefully you can kind of see how it works. This is also true. East Coast states do border the Atlantic Ocean. Final one, Valentine's Day is in February. So one way that we could write this is we could say, if it is Valentine's Day, then it is February. That would be a conditional statement. And that's also true because Valentine's Day is in February. So that's how you write conditional statements when you're given kind of just a blanket statement with a hypothesis and conclusion. It has to be if-then format. So it has to have the words if and then in there. Now, one other version of a conditional statement is the converse. So the converse of the conditional statement just means that you swap the hypothesis and conclusion around from the original statement. This is what it looks like kind of in symbol notation. So here we started off, the conditional statement would be if P, the hypothesis, then Q, or P implies Q. For the converse, we're going to switch them around. So now it's if the conclusion, then the hypothesis. So now Q implies P. So if we start off with a conditional statement, this is just an example. If a state is on the East Coast, then it borders the Atlantic Ocean. If we write the converse of this statement, it would read, if a state borders the Atlantic Ocean, then it is on the East Coast. So converse, you're just switching around the hypothesis and the conclusion. We do this with a lot of theorems. That's why the converse is pretty important here. Look at some examples. So converse examples, we're going to write the converse of each conditional statement and determine its truth value here. So first statement says, if it is Saturday, then there is no school. This is pretty much true unless you get Saturday school. Now, if we write the converse of this statement, there is no school would be first, and then it is Saturday would come second. So it would read, if there is no school, then it is Saturday. So again, converse, you're just switching them around. Converse, switch. If there's no school, then it's Saturday. This is false because it could be Sunday. It could be Labor Day, which is a Monday, this next Monday. Then we have the second conditional statement. If the temperature is 25 degrees Fahrenheit, then it is below freezing. That's a true statement because 32 degrees Fahrenheit is freezing temps. Which, if we write the converse of this, it would say, if it is below freezing, then the temperature is 25 degrees Fahrenheit. So again, converse, you just switch the hypothesis and the conclusion around. And if it is below freezing, then the temperature is 25 degrees. This is false because it could be any temperature below 32 degrees. It could be 26 degrees Fahrenheit. All right, let's look at the next verse. So our next type of conditional statement is the inverse. So the inverse, there is no switch, so we don't switch. But what we do is we negate both the hypothesis and conclusion. Negate means to just change it to the opposite meaning. So usually just adding the word not into a sentence kind of works. Here's the symbolism. So again, if we have a conditional statement, if P, then Q. Inverse is if not P, then not Q. So all you're doing is really just changing the actual meaning of your hypothesis to not the hypothesis, so the opposite of it. Here's an example to help better make sense of it. So again, if we start off with a conditional statement, if a state is on the East Coast, then it borders the Atlantic Ocean. So now if we're doing the inverse, it would read, if a state is not on the East Coast, then it does not border the Atlantic Ocean. So again, notice that there is no switch here. All you're doing is really keeping the same order of the conditional statement and then adding the words not in there, or really we're just trying to change the original meaning. So here it says if a state is on the East Coast. We could say if a state is not on the East Coast, if a state's on the West Coast, I don't know. But really just changing the meaning of it to the opposite of what it originally read. Adding the word not is usually the quick way to do it. So let's look at another example. So writing the inverse, we're going to write the inverse and determine the truth value. If we start off with this statement again, if it is Saturday, then there is no school. It would be in the same order, except now we would add in the word not. So if it is not Saturday, then there is school. Well, this isn't true either because it could be Sunday. If it's not Saturday, it could be Sunday. Sunday, we don't have school, unless you count Sunday school, I guess, for church or whatnot. But I think in this meaning, we actually mean school. The second one is if the temperature is 25 degrees Fahrenheit, then it is below freezing. Again, we saw that this was true. So inverse would be if the temperature is not 25 degrees Fahrenheit, then it is not below freezing. So if it's not 25 degrees Fahrenheit, it can be any other temperature other than 25 degrees that is not below freezing. That's not true because, again, we could have like anything under 32 degrees and it would still be below freezing, I guess. So we could have like 26 degrees. So it's not 25, but it is below freezing. So this is actually not a true statement. So there is a little line of thinking going on where you're trying to determine if it's true or false. All right, and then the last one here is contrapositive. So contrapositive of a conditional statement is where we're going to switch and negate. So we're just going to jump right to the example. Conditional statement, if a state is on the East Coast, then it borders the Atlantic Ocean. So we're going to negate and switch, or switch and negate. So it would be if a state does not border the Atlantic Ocean. So again, we negated and we swapped it around, then it is not on the East Coast. So again, you could pause this to try to make sense of this. All we're doing is we're basically doing a combination of the converse and the inverse. That's what the contrapositive is. Let's look at an example here. So contrapositive example is we're going to determine the truth value here. If it is Saturday, then there is no school. So again, this is traditionally a true statement. Contrapositive would be if there is school, because again, this is no school. So if there is school, then it is not Saturday. So we're switching the order around and we're negating it. So we're changing it from its original meaning to the opposite. So if there is school, then it is not Saturday. So again, this is a true statement. So if you have school, then it's not Saturday, but unless you're naughty and get Sunday school or Saturday school, I guess. And the other one is if the temperature is 25 degrees, then it is below freezing. So this would be if it is not below freezing, then the temperature is not 25 degrees. So if it is not below freezing, that means it's above 32 degrees Fahrenheit, then it is not 25 degrees Fahrenheit. That has to be true because it has to be above 32 degrees Fahrenheit. All right, and then real quick, we are going to look at one last example of just a conditional statement called the biconditional statement. This only works if the conditional statement and its converse are true. So we have to use the converse. Again, converse is when you just switch the statements around. So if we start off with a conditional statement, if a state is on the East Coast, then it borders the Atlantic Ocean. That is a true statement. And then the converse is if a state borders the Atlantic Ocean, then it is on the East Coast. These are both true statements. So again, if your original statement and its converse is true, then that means it's a biconditional. So we can reword this as a state is on the East Coast if and only if, this is what makes a biconditional statement here, the if and only if part, it borders the Atlantic Ocean. Now, you could also use the converse and say a state borders the Atlantic Ocean if and only if it is on the East Coast. You could say that as well. But again, biconditional only works if the original and the converse is true, and then you can rewrite it as this biconditional is if and only if. Okay, we're going to just look at an example, and then we'll wrap this up here. So, biconditional example would be, we're going to determine if this statement can be written as a biconditional statement. So, start off, if today is Wednesday, then yesterday was Tuesday. So, if today is Wednesday, then yesterday was Tuesday. That's a true statement. Converse of that is swapping them around. If yesterday was Tuesday, then today is Wednesday. So, that word it shouldn't be in there, but if yesterday was Tuesday, then today is Wednesday. So that's true as well. So the original statement and its converse is true. So that means that we can write this as a conditional statement here. And we could write it as today is Wednesday if and only if yesterday was Tuesday. Or we could say yesterday was Tuesday if and only if today is Wednesday. All right, and then one final example. This is just more of a summary. If you skip the rest of the video up until now, maybe you might be able to get all of this kind of down. So what we're going to do is write the inverse, converse, contrapositive, and see if we can write the biconditional for this following conditional statement. And we're going to determine the truth value of it as well for each one. So if we start off with a conditional statement, it says, if you live in Indiana, then you live in the United States of America. That's a true statement. If you live in Indiana, then you live in the USA. The converse is, if you live in the United States of America, then you live in Indiana. So converse is you're just switching them. And this one is false. Because if you live in the United States of America, you could live in any state. It doesn't have to be Indiana. The inverse, and again, whenever we're doing the inverse, we're doing it from the original statement up here. So we're using the original conditional. So if you live in Indiana, then you live in the United States of America. The inverse of that would be we're not switching at all. It would be if you do not live in Indiana, then you do not live in the